Okay, so this is the standard. I can calculate the B field for long straight wires and circular loops. That's problem 56 from chapter 28. It says two very long straight wires carry currents as shown in the figures. They're kind of just crosses. I drew like 3 of them there. And with in each case, whatever the currents are given. And then they want us to find all locations where the net magnetic field is 0. So the first one, I thought it was pretty easy. There was just 10 amps going this way, 10 amps going this way, so it seemed like they would be canceling each other out whenever they were equal distance from each other. So I just drew a line this way, and so that's where it's going to be equal to 0. And B was harder, so I'm going to C first. And then C was the same thing, just with 20 going this way and this way. So these were the places where I said they were 0 was just along this axis. I don't know really how else to describe those. They're just this distance and this distance are the same. And then here in B is where I am not quite sure. But since there's 2 different currents, I think that it's either going to be along this line or this line. Like this would be the slope, but I don't know. It seems like this wouldn't. I don't think that's how it would work. Because I think if it was over here, it would feel more of a. It would feel more of the field from the 10 amps going that way than the 3, which makes me think that it's this one, because in this case this would be farther away from the stronger current and closer to the weaker current, so I think it would be balanced out along here, so this would be equal to 0. Because yeah, I think that makes more sense now. Glad I drew 2 lines. Yeah, so it's not this one because that would be too close to 10. It has to be this one because it's close to the weaker current and it's further away from the stronger current. So that's where it would be balanced out, is along this line.